Okay, welcome to the Man in the Middle section. This is where we can relax a little bit since we covered all the important things that an ethical hacker must know. From scanning, from exploitation, to gaining access with Trojans and web application penetration testing. Now we can lay back and cover something that you won't need that much, but it is a cool attack that allows you to sniff information inside of a local area network. Now, in network penetration testing, this is something that you also want to try. In some networks, there will be protection that blocks this type of attacks. However, to this date, many home networks, schools and company networks don't have this applied. Anyway, before we actually get to run this type of the attack, let's first talk about how does it work. Let's start like this. Now, imagine a home network with many devices. Say we have 2 computers and also our Cal Linux machine inside of that network. Networks also have routers that route their traffic to different websites. And every time that you, for example, communicate with a web page, you do that through your router. You request a web page and a router will forward your request to that server, and when the server sends a response to you, the router will send it to your machine inside of the network. But how does it know which machine to send to? How does it know to who to forward which packet? Well, let's explain it like this. Let's go back to our 3 machines and let's mark them with A, B, and C. All of these machines, including our routers, also have an IP address. So we can say A has 192.168.1.10, B has 192.168.1.5, our Cal Linux machine has 192.168.1.7, and our router has 192.168.1.1. Besides having an IP address, all of these machines also have their MAC address. And these two help them communicate with each other over the network. Our router knows who to forward the packets to, thanks to ARP packets and ARP tables. Now, we're going to talk about ARP packets in just a second, but what I want to mention for now is that our router has ARP tables that map every IP address inside of the network with their MAC addresses. Then it uses the machine's MAC address to forward the packet to them. We know by now that MAC addresses are unique, therefore by knowing them, you know the ID of that machine and then you can communicate with that machine. Now, let's explain those ARP packets. What are they and how they allow us to communicate with each other? Well, to explain this, I will remove one machine just for the simplicity. Okay, so there are 2 types of ARP packets. We have ARP requests and ARP replies, or ARP responses. Now, with requests, we find out what machine has what MAC address, and with ARP replies, we reply to that machine that asks the question with our response. Request would look something like this. Let's say machine A wants to communicate with our Cal Linux machine. To do that, it must know our MAC address, so it sends the ARP request to the broadcast address, which simply means every machine on the network will get that ARP request. And with that ARP request, the machine A asks who has an IP address of 192.168.1.7. And it also tells, send me your MAC address if this is your IP address. In this scenario, our Cal Linux machine receives the request and it gives an answer. It says, I am 192.168.1.7 and here is my MAC address. Now, this is just normal communication in any network. This is how machines and our router figures out to who they should forward a certain packet. However, there are ways that this can be abused. For example, what if I, from my Cal Linux machine, craft an ARP response and send it to machine A saying that I am 192.168.1.1, which is the router. We know that machine A uses router to communicate with the internet, therefore, once we send the machine A an ARP response and tell it that we have an IP address of the router, it will start sending its packets to us instead of the router. For example, let's say machine A wants to visit Facebook. In this case, it would send that Facebook request to us instead of directly sending it to the real router. Well, you might be asking, what now? We just managed to redirect the traffic of machine A to go to us, and now that machine won't be able to access internet because the packets are not being forwarded to Facebook or any other page that they want to visit. Well, not exactly. We can also send an ARP response to the router. In this response, we tell the router that we are the machine A. Now machine A believes that we are the router, and router believes that we are machine A. All we are left to do in this case is forward the packets to keep the connection going. So in this scenario, instead of communication to websites going like this, instead we spoof the network and now the communication is being done like this. In this case, if machine A tries to visit facebook.com, for example, it will send that request to us, which we then forward to the router, and the router forwards it to Facebook. Like this, we can sniff the data if it is unencrypted, and we can also see what websites is machine A visiting. And this communication works both ways. Once Facebook receives machine A request, it sends the response that comes to our router, and then since router is also being spoofed, it thinks that we are machine A, and it sends back the response to us. Then we forward the response to machine A, so machine A has no idea that it is being spoofed since it is able to visit any pages and websites. This attack is called man-in-the-middle with the help of ARP spoofing. And of course, when we perform this attack and we spoof our router and targets, their ARP tables will look something like this. The MAC address of machine A changes to our MAC address inside of the router's ARP tables. And that is while it's being spoofed. Once we stop the spoofing, the MAC address changes back to its real MAC address. Okay, great. Now that we know how exactly the attack works, let's mention a few things that we might want to get once performing this attack. The goal of it would most likely be to overall be able to sniff the data going from other machines on the same network. We also want to be able to check out what websites are other machines visiting, and if possible, in case some communication is not encrypted, we would want to sniff passwords if someone tries to log in to some page. Just most of these things depend on which websites are they visiting. Nonetheless, now that we know theory behind the attack, let's see how we can perform it using different tools. See you in the next video. Welcome back. Let's start with our first tool that we're going to use to perform ARP spoofing and man-in-the-middle attack. Now, for this type of the attack, there are many tools out there that you can use to initiate this attack. Some of them are outdated, some of them are already pre-installed in Cal Linux. However, we're going to cover one of the most known tools, which is called BetterCap. It is a little bit harder to use, however, we're just going to cover the basics of it. So let's open up our terminal, and since this tool is not already installed in Cal Linux, we must install it first. And my advice would be for this entire section to run all the tools as a root account. Now you might be asking why? Well, we're going to perform a bunch of different networking things, and some of the networking things could require root privileges. So some of the tools might not run, some of the settings might not work if we run it as a regular user inside of our Cal Linux. So let's real quick enter the root terminal. And to install our BetterCap tool, we can simply type the command apt-get install and then BetterCap. Press enter, press Y once it asks you do you want to continue, and now we're going to wait for the BetterCap installation to finish, and then we're going to enter its framework and perform MITM attack. Okay, it has finished. Now, there are two ways that we can run this attack. We can run it as a command by specifying a file that contains all of the BetterCap commands that we want to run, or we can run it inside of the framework. Now, for the first try, we're going to just type BetterCap to open the framework, and we're going to experiment with different commands in order to run this attack. And then after this, we're going to see how we can run it just from a terminal in a one-line command. Okay, so once you type BetterCap inside of your terminal, it will open the BetterCap program, it will tell you which version it is, and it will also tell us to type help for a list of the commands. So let's type help to see what options do we have, and right here we're going to see a bunch of available services that we can run with BetterCap. Most of these services are not going to run, as it says right here not running, and the only one that you will see running is events.stream. Now, you might already start to notice something interesting for us, such as for example this ARP spoof. We talked about ARP spoof in the previous video, and we know that this is the base of our man-in-the-middle attack. However, before we get to it, let's go a little bit up and check out the help menu. So these are the commands that we can use with BetterCap. We can type help and then some module name in order to print out more information about that specific module. We can also active, quit, sleep for a certain amount of seconds. We can set value the same way that we do inside of our MSF console. If you remember, once we set values for certain payloads, we do that using this command. So we can assume that this is something similar as an MSF console, or at least it has similar options and commands. Now let's go down to these modules, and before we actually get to this ARP spoof module, let us take a look at this net probe module. If I simply just type help and then net.probe, this will give me the help menu and the description of this module. So as it says, it will keep probing for new hosts on the network by sending UDP packets to every possible IP on the subnet. In other words, what this module will do is it will discover all of the online hosts inside of our local area network. So what we can do is we can turn that on to start network host probing in background. Let's run this command as it tells us right here. Copy this, paste it right here, and let's press enter. And we can already see that it managed to discover some of the hosts inside of my network. These are the active IP addresses right here. The next thing that we want to do is we want to type the help menu for the arp.spoof module. So just type help arp.spoof and press enter. And we also get the option as to how we can run this module. But down here we can see some additional options, or as it says right here, parameters for this module. We got arp.spoof.fullduplex, we got arp.spoof.internal, arp.spoof.targets, and arp.spoof.whitelist. In this specific scenario, we're interested in these two, so the full duplex and the targets. The full duplex, if we read the description, if this is set to true, both the targets and the gateway will be attacked, otherwise only the target. And as it says right here, if the router has ARP spoofing protections in place, this will make the attack fail. So in some networks and on some routers, this attack will not work because more and more routers nowadays are starting to implement the ARP spoofing protection. However, if it is not enabled, if the protection is not enabled, then we can perform this attack. So what we must do is we can type set arp.spoof.fullduplex to be equal to true, or just set it to true. Press enter right here. And we also want to set the targets. Now you can specify the entire subnet or the entire network, or you can do it like I'm going to do. I'm just going to select one target. And the reason why I'm selecting one target is because once you run this on the entire network, there is a lot of information going inside your terminal. And it is going really fast, so you don't even get to read it. Therefore, what I'm going to do for the purposes of this tutorial is I'm going to select the IP address of my Windows 10 machine that we're going to perform the MITM attack on. And then I'm going to set arp.spoof.targets to be equal to that IP address, just like this. Once I do this, I want to start sniffing for the network connections. And we can do that if I go up here. We can see that there is a module called net.sniff. If I type help net.sniff, it will just say that this will sniff packets from the network. And the command that we use to start it is net.sniff. But before we actually start it, let's go and check out the parameters right here. The parameter that we want to use for this attack is net.snif.local. As it says, if this is true, it will consider packets from to this computer, otherwise it will skip them. Now, once we start the ARP spoof attack, all of the packets from our target machine will go to this computer, therefore this will be able to sniff them. Let's copy this and paste it right here. And what we want to do is we want to set this to true. After we get all of these settings ready, we can type arp.spoof and we can set this on. And we can also type net.sniff on. Press enter and this will start sniffing packets on our Windows 10 machine. We can also see some of the queries that our Windows machine is making. And if I go and try to visit some web page, we can see that our target machine is querying Facebook. As we can see, the desktop machine initiated the request for www.facebook.com. And this will work for any other website. We can see the requests for twitter.com. And if they were to input a password to an unencrypted website, such as for example, let's say that they want to connect to our router and go right here, and they type for example test and click on login. If I scroll a little bit up, we should manage to find the request where they send the password. And here it is. Here is the request where they send the password. We get the username test and the password is a hashed value. However, we managed to get it nonetheless. It will work for any website that sends unencrypted data. For example, onto this website called vulnweb.com, if I go to first link, which is this one, and I click on login, type username admin and password test, I click on login, and for some reason it seems that it didn't manage to get it. Let's just scroll a little bit up to see whether we can find it, and here it is. Here is the packet that we sent, including the username and the password. We managed to sniff it from our Windows 10 machine. Here is the username admin and the password test. Great. This is one way that you can use BetterCap. Another way that you can use BetterCap is if I exit out of this program, it will automatically start the ARP spoof and it will restore our cache for our one targets. And the way that we can run it with a command is we can just create a file called sniff.cap. And inside of this file, we can type the commands that we typed previously, which is net.probe on. We also want to select arp.spoof.fullduplex to true in order to also spoof the target and the router. And we also want to select arp.spoof.targets to the IP address of our target machine. After that, we set the net.sniff.local to true, which means only sniff the packets that are coming from and to this machine. And then we type arp.spoof on and net.sniff on. These are all of the commands that we must run, so all we need to do is save this in a file called sniff.cap, and then we can run the command bettercap-iface, and iface stands for interface, where we need to specify the interface of our machine. Since on Kali Linux, the only active interface that I have is ETH0. Once I specify that, all I need to specify is another option, which is -caplet, and then the name of the file containing our commands. And this will do everything that we just did automatically. So if I press enter, it will set all of the settings that we did, and it will start sniffing for different connections. For example, if I go right here and try to refresh Facebook, it will sniff that request to Facebook. And this is one way that we can perform man-in-the-middle attack. In the next video, we're going to check out another tool that will allow us to perform this attack that you might actually find a little bit easier to use. So thank you for watching, and I will see you in the next video. Welcome back. Let's cover another tool that we can use for man-in-the-middle attack. And this tool is called similar to the previous tool from the last video. This tool is called BetterCap, just without B. Now, unlike the previous tool, we already have this pre-installed inside of our Kali Linux machine, and this is a graphical interface tool. So it might be a little bit easier for us to run it, and let's give it a try. What we must do first is we must open the terminal, and as I already mentioned in the previous video, let's run all of this with root account. Now, before we actually start running this tool, I want to talk about another thing which is called manual packet forwarding. So sometimes some of the tools will not perform the packet forwarding for you. And if you don't do it yourself, sometimes even after performing the ARP spoofing and the man-in-the-middle attack, your targets will not be able to visit pages because you didn't allow packet forwarding. To always make sure that your packet forwarding is allowed, you can cat out the file at location /proc/sys/net/IPv4 and /IP_forward. Once you cat this file, you will either have a value of 0 or 1 right here. If you have a value of 0, that means the packet forwarding is not enabled, and in that case, you must enable it first. To do that, you can type echo 1 and you echo it into this location. So proc sys net IPv4 and IP_forward. And then you double check to see whether the value of 1 has been added to this file, and it indeed has. Now the packets are allowed to be forwarded. Once you do that, then you can start your tools. So to start the ethercap tool, all we need to do is to type ethercap-g. Oops, it says ethercap not found. Let's give it a try. Maybe it is not installed by default. Let me see. Unable to load ethercap. Maybe it is lowercase, so if I type it like this. Okay, so now it works. Just make sure that you specify it with lowercase e at the beginning. Then you type ethercap and then -G for graphical interface. Once you do that, it will open this new window, which is the new version of ethercap that is a little bit different than in the previous Kali Linux versions. You can enlarge the window, and the first thing that we must do right here is to set up the interface and the sniffing at startup. So you can turn this on. You can select your primary interface in case you're over Kali Linux. It will usually be ETH0. Unless you're running over wireless, then you want to choose a different interface, and once you do all of that, you can click on this check button right here, which says accept, and it will tell you down here started unified sniffing. Now, what I usually like to do is I like to enlarge this lower window a little bit more to see everything better, and then we can experiment with different ethercap options. The first thing that we must do once performing this attack is to discover all of the hosts on the network. To do that, you can type on this button right here. It will even tell you that this button is used to scan for hosts, and once you click on this, it will automatically scan all 255 hosts on my network, and it will tell me 4 hosts added to the host list. But right here we cannot really see the hosts, so how can we see which hosts are discovered? Well, we can go onto this button right here. Click on it, and it will tell us the IP addresses of the hosts and their MAC address. Down here, also these buttons will open. Delete host, add to target 1, or add to target 2. And as in the previous video, we're going to perform this attack on our Windows 10 target machine. Or in my case, I'm going to perform on my Windows 10 target machine. You can choose whatever machine that you want. Since the IP address on my Windows 10 machine is 192.168.1.7, I'm going to right click on this and add to target 1. To check out whether I successfully added, I can take a look down here, and it does say host and then this IP address added to target 1, but I can also go to these 3 dots, click on targets and click on current targets, and it will tell me that I have the current target of 192.168.1.7. Once I select my targets, I can start ARP poisoning, and to do that, I click on this right here, which says MITM menu, and we got different types of poisoning, but we're interested in this ARP poisoning. Click on that, and click on OK to start sniffing remote connections. It will tell us down here ARP poisoning victims, group 1, which is the only target that we specify with its MAC address, and the group 2 will be all of the hosts in the list, but we don't have any, so currently we're attacking just the Windows 10 machine. Now there is one thing about this tool, it will not print nearly as much information as the previous BetterCap tool. However, once our target visits a page that sends unencrypted usernames and passwords, it will print that right here. And we can take a look at that by going to our router, as in the previous video, and typing in, for example, admin and then password. If I click on login, down here we will manage to sniff that. As we can see, the HTTP, it will tell us from where did the connection come from, the username is admin and the password is this. Now this is once again the hashed value of the password because that is how it is implemented inside of our router. If it was some page that was sending the passwords in plain text, we would be able to see it right here in plain text. Okay, so now that we did the same thing from the previous video, I also want to show you a cool trick that you can check out to see if the target machine is being ARP spoofed. So let's say that we are on our target machine, and this is the machine that is currently being ARP spoofed. How can we check out whether our connection is being sniffed? Well, we can open the command prompt and we can type the command arp-a. And this will give us our ARP cache, or in other words, this will give us the IP addresses of the machines in the local area network and their correspondent MAC addresses. And if we take a look at right here, we can see that all of these IP addresses right here appear to have the same MAC address. And that is not a good sign. Once you see something like this, or if you even see two different IP addresses having the same MAC address, that is also not a good sign, and that would most likely mean that a man-in-the-middle attack is being performed, especially if you have an IP address of router having the same MAC address as a different machine on the network. And this is how you can check this out. For example, if I stop this, let's go right here and quit this program, stopping the MITM attack, and closing this. And if I go and run the same command, now you can see different IP addresses have different MAC addresses. And this is how it should be because the MAC addresses are unique. So one IP address should have one different MAC address. And not like this where we had all of the IP addresses having the same MAC address. Now, in the next video, we're going to take a look at how we can perform this manually using Python 3. We're not going to be sniffing for data, we're just going to see how we can change the MAC address of the router from our Kali Linux machine to appear as the same MAC address from the Kali Linux machine to our Windows 10 machine. Or in other words, if you didn't understand, we're going to spoof the Windows 10 machine with one packet just to change its ARP tables. And we're going to do that using Python 3. So that would be about it for the AtterCap tool. You can experiment with other options as well if you want to, and I will see you in the next video. Welcome back. In this video, we're going to take a look at a cool way that we can actually perform ARP spoofing or ARP poisoning manually. We're going to do that using a huge library that comes with Python 3, and that is called the Scapy library. Now, Scapy allows us to manipulate different networking packets, and we can also send and receive the packets as well. Now, we could do something like this with the help of a socket library, but that would be much harder. Because with the help of Scapy, we have all of the packets already predefined, and we can just craft them to our liking. Now, the same way that you can open Python inside of the terminal, you can also open Scapy inside of the terminal. And this will allow you to write the code line by line. So it will take a few seconds to open this framework, and once it opens up, you will see this Scapy banner, and then you will be able to run the commands right here. Scapy works similarly to Python, so you can use the print statements to print hello world, for example, and it will also run that code as well. However, we're not going to use it for this. We're going to use it to craft packets. For example, there are attr headers inside of a packet, and to see all of the fields that an ether header has, we can type ls and then ether. The same way we can do for the arp packets. For example, if I type arp inside of the brackets, it will give me all of the fields that an arp packet has. And you can do that for any packet that you want. For example, you can also do it for TCP packet, and it will give you all of the fields that the TCP header has. And then you can change each of these fields to your liking. But as I already mentioned, the goal for this video is for us to craft an ARP packet that will poison the ARP cache of Windows 10 machine and that will tell our Windows 10 machine that we are the router. So how can we do that? Well, first, if you remember, we must know the MAC address of our Windows 10 machine to be able to send the ARP poisoning packet to it. Now we're not going to cheat and check out the MAC address inside of the command prompt on Windows 10, we're going to get it using Scapy. To do that, we must send an ARP request that we request the MAC address of the Windows 10 machine. To do that, we must also send that request to the broadcast MAC address, which, if you remember, means that every machine on the network will receive that request, and then hopefully our Windows 10 machine will reply with its MAC address. So to do that, let me see if I can use clear command right here. Okay, great, I can use it. To do that, we are going to combine the ether header that we just checked out with the ARP header or the ARP packet. The reason we need the ether header is so we can specify the destination MAC field to be the broadcast MAC address. Therefore, our ARP packet will be received by anyone on the network. Let's do that. So let's create a variable called broadcast, and this variable will be equal to ether header, and the dest field, which is the destination, we can set to the broadcast MAC address, which is for everyone 6 times FF separated by 2 dots. Once you do that, you can close the brackets, and now we got our broadcast packet ready. To check out whether everything is selected correctly, we can type broadcast.show. And this will show all of the fields that we have right here. And you will notice that it will automatically set the other 2 fields. This is the MAC address of our Cal Linux machine, which is the source MAC address because we're sending the packet from our Cal Linux machine, and the destination is to who we are sending the packet. In this case, we're sending the packet to everyone. Now what we must do is we must also create the ARP layer to this packet. And to do that, we can type ls-arp first to check out all of the fields, and we want to target the Windows 10 machine because we want to get its MAC address. So what we must do is we must type the p destination to be equal to the IP address of Windows 10 machine. All the other fields will be set automatically for us, except this hardware destination field, which is the MAC address of our target, which we get from the ARP response. So to craft the ARP layer, we can type ARP layer equals and then ARP, and inside of the brackets we specify the fields that we want to use. In this case, we only specify the p destination to be equal to 192.168.1.7, or you can just specify the IP address of your target machine. Press enter, and before I explain this, I can just type arp.show to show you how the packet looks like. So it will select the hardware source to be our MAC address, it will select the p source to be our IP address, it will select the p destination to be the target's IP address, which in our case is 192.168.1.7, and the hardware destination will be empty because this is the value that we want to get back. This packet is essentially saying, who has 192.168.1.7, give me your MAC address. And to combine this packet with our broadcast layer, we can type entire_packet equals broadcast/ARP layer. And this will put our 2 layers together. If I type entire_packet.show, you will see we have both the Ethernet layer and the ARP layer. Only thing we must do right now is we must send this packet to our network. We can do that using srp function, and this function takes arguments of entire packet. We can also set the timeout to be 2, and we can set the verbose to be equal to true. Now, this is not something that we want to send. We want to store the response inside of the answer because if the Windows 10 machine answers, we will have our answer with the Windows 10's MAC address right here in this variable. We also want to only get the answers and not the unanswered packets, and we can do that by specifying right here 0 to select the first element inside of the list. Once we do that, we can press enter and we get operation not permitted, and that could be because we are not root account. So what I'm going to do is I'm going to run this real quick as root. So I'm just going to write all of the commands that we just did, and I will get back to you as soon as I get to the srp command. Okay, so here we are. Now we made a mistake that I already talked about. We must run all of this as a root account, otherwise some of these commands will not work. And I just typed all of the previous commands that we did, such as setting the broadcast layer, ARP layer, and creating the entire packet. And now we're sending the entire packet with this command, and we're storing the response in the answer variable. So let's press enter, and it will tell us finished sending 1 packets, received 1 packets back, and got 1 answers. Now to get this answer, it's a little bit tricky. So if I type print answer, we will get this response right here. And since all of these are empty, we want to select this other part right here and print just that part. To do that, we can type print answer and then the first element, which will be the answered packets. So in the brackets, we specify 0, press enter, and this is our response from the Windows 10 machine. If we take a look at the response right here, we're going to see the MAC address of Windows 10 machine. So we successfully received it with our packet. Now, we can either copy it from here and store it in a variable, or we can select it like this. So we're going to print the answer, and from the answer we are selecting the first element, and from the second list we are selecting the second element, and we're going to type .hwsrc. And the reason we are using hwsrc is because this is the field that has the MAC address of our Windows 10 machine, or of our target machine. Then if I print this, it should print just the MAC address, and here it is. And all we need to do right now is copy this and store that in a variable that we can name target MAC address equals, and then our answer with the HW source field. Great. Now we got our target's MAC address, and we are ready to craft the malicious ARP packet. So what we can do is we can type something like this. The packet will be equal to ARP packet, and we're going to select the OP field to be equal to 2. Now if you type ls ARP, you're going to see the OP field, and this OP field is simply just asking, are we sending ARP request or ARP reply? Once we select the field to be equal to 2, this means we are sending an ARP response. And remember, to send a malicious ARP packet, it must be an ARP response telling the router that we're Windows 10 machine or something similar to that. Once we set the OP to be equal to 2, we must set the hardware destination to be equal to target_MAC_address. And from here, we are selecting 2 more fields, which are pDestination, to be the IP address of our target. So this simply means that we are sending this packet to our target. And the last part is where we add the malicious thing. Here under the P source, in a real packet, in real communication, we would specify right here the IP address of our Kali Linux machine. But in this case, we want to pretend that we are router. So we're just going to specify the IP address of the router. And this right here is our malicious packet. If I type packet.show, you will see it right here. We have the MAC address of our Kali Linux machine, but we also pretend to be the router. We typed the router's IP address instead of our own. And this packet is being sent to this destination. Now, before I send it, I'm going to open the command prompt on my Windows 10 machine, and I'm going to run the arp-a command from the previous video, just to see how the ARP tables are currently being set. So we can see that the router, which is in my case 192.168.1.1, has this MAC address. Our Kali Linux machine, which is 192.168.1.10, has this MAC address. And you will notice once I send this packet, this IP address, which is our Kali Linux, and the router's IP address will have the same MAC address. And that is an indication that the ARP spoofing attack is taking place at that specific time. So let's send the packet, and to do that we can use the send function. The first argument is going to be the packet, and we can set the verbose to be equal to false, and press enter. If I go back to command prompt and type arp-a again, we can see now router has the same MAC address as our Cal Linux machine right here. So we successfully ARP poisoned the ARP cache of our target machine. Now that we did this, you probably now fully understand how ARP poisoning works. And you can also take a look at different tools online to see if there are some better tools that you can use to perform man-in-the-middle attack. Some of them have more options, some of them have less options, but nonetheless, this is all it is about this attack. You simply just send a malicious ARP packets and redirect the connection to you. So thank you for watching this video, and I will see you in the next section.